Hey, this is for checkpoint 1.18, and we're building on the idea of the fundamental theorem of calculus part 1. Pay no attention to the part 2. Those are next videos. With this problem, one of the things that we want to be careful about is how we're not starting from 0 and moving up to some random variable like x or x squared. Instead, we're starting at x, and then we're going to go from x all the way up. We have to be careful. So let me go ahead and capture this for you over on the visualizer. There we go. And so we have f of x, or capital F of x, equals the integral from x to x squared of cosine t dt. If you watched the last video, one of the things in that video was, what do we do with like cosine, the integral of cosine? How do we treat it? To set this problem up, the first thing we need to do is actually think about how x and x squared are variable limits of integration. And all of the work that we've done so far was a constant to a limit of integration. So we're going to actually break this up into two functions. The first one is going to be the integral, let me make sure I'm capturing this right, from x back to 0, right? If we can relate things back to 0, of cosine of t dt. This is technically going to be a problem I'll fix in a second. But then we can also add that, right? You can add, if you can break up this interval right here from x to x squared, if we can break up that interval, then we can go from x to 0, and then we can go from 0 to x squared. This would be like looking at two separate sections. It's the same curve. It's still cosine. It's just that instead of going from x to x squared, we're going to look at some constant that we know definitely splits this function into two sections. Therefore, the integral would be split into two sections. Here's the issue. We don't know if x and 0, if x is positive, if x is negative. I guess x should be, well, it doesn't matter. The point is, it doesn't matter. We're going to let the calculus and our ability to handle negatives and some integral rules take care of things. So first of all, it should probably be 0 to x. In order to flip the limits of integration, we have to also include this negative symbol. So the negative sign is what lets us flip 0 and x around. Then it's still cosine t dt. Now over here, we would have the integral from 0 to x squared. Nothing changes for this second integral because it's a constant term as the opening limit of integration, and then it's the variable term as the second one. Note, caution, let's call that u, which means we also need to know u prime, 2x. Now, that's a way to break up any integral where we have variable limits of integration, both of them being variable limits of integration, where we go from x to 0 and then from 0 to x squared. Technically, going through the thread is actually the same as going from x to x squared directly. But we need to have this constant term in the bottom to know what to do with it. The derivative, okay, the derivative f prime of x, therefore, is the derivative of this antiderivative. So the derivative things cancel out, and we're left with just the integrand function, cosine. Now we consider our 0. When you use a 0 in this problem, you're going to generate a constant, and so therefore the derivative of a constant is 0. But the upper limit of integration that's a variable will be x, and of course throw in the negative. On the other side, right, this is the other side. In the additional integral problem, this antiderivative is going to be differentiated. So therefore, we're going to be left with the integrand on the inside plus cosine. But instead of t, we're going to use that x squared, that upper limit of integration that is an expression all on its own. So that's going to become the limit, or the argument of cosine. And then if you're going to use the chain rule, where we have to chain rule problem, we got to furthermore multiply by the derivative of that other thing. So multiply by the derivative of x squared, which would be 2x. Okay, so therefore, as we have it, the antiderivative, I'm going to move this all around, I think, nicely. 2x cosine of x squared minus cosine of x. Should we think about some of the properties that we can do with that x on the inside? Yeah. Is it necessary? No. We have an equivalent expression. Thanks for watching this video.